While you're watching this audio portion of this study guide, again, listen to key things I'm talking about to help you for the final, and then be listening for the secret message. So here we go. For that first problem, I'm going to find out what I'm going up by, find out how many circles in each step. So there's 3 in that first step, 7 in that second, 11 in that third. I can see that I'm going up by 4 each time. So from here to here is 4, from 7 to 11 is 4. That going up by 4 makes that an arithmetic sequence. That would be linear straight line. I need you to make a slight change on your study guide here. Instead of this being +4, I need you to change that to +3 right there. So again, this is asking which of these 3 choices shows this progression above. For this problem here, to get this right, you need to know the formula to find the explicit function for an arithmetic sequence, where you use the first term, f of 1, and then you use d distributed times x minus 1. So again, if I plug in f of 1 and d into that formula to find the explicit function for this sequence, that would be f of x equals 3 plus, and then where d used to be, I plug in 4. And again, I could put that on the front side of that parenthesis, or I could put that 4 on the back side. Same math, you're still going to distribute and combine like terms. So again, if I was to distribute this, that would give me 4x minus 4, and then combining like terms would give me 4x minus 1. So the only choice of these 3, which is good, is choice C, where I have F1 plugged in here and D plugged in 4 right there. This one has the proper D, but has the improper y-intercept number, because again, at the 0 term I get -1, so that would be incorrect. This, with the correction being a 3 right there, is the recursive form, but it has the wrong D number, so the wrong common difference, so that would be the incorrect answer too. So make sure, with that being the 3 right there, that is an improper choice. Alright, for the next problem, it's having you find how many circles in design 0. So I'm going to be going back a step. So I know my first step I have 3, and my second step I know I have 7. So again, I'm going up by 4 going to the right. So if I go back a step, I'm subtracting 4. So if I subtract 4, of course 3 subtracting 4 gives me -1. So my number of circles in this sequence here for this example would be a -1 right there. It's going back. So again, if I put that together for arithmetic sequence explicit function would be 4x minus 1, or I could get that same answer by plugging in the first term here and d, distributing and combining like terms to get that same 4x minus 1. Alright, for number 3, to find how many circles in design 25, I'm going to find again the explicit function for this sequence, and again I'm going to change that to a 4 right there, so that should be a 4. So again, I could either use the explicit function where I use the 0 term and then 4 right there, d, or I could again use this first term here and d here to get that same 4x minus 1, and again I'm going to fix that to be a 4. Again, to find that 25th term, just take that explicit function, 4x minus 1, and evaluate it for 25. So here we go, I'm making that change to make that correct. So there we go, there's the explicit function. So here where that x used to be, I plug in 25, and I have that -1. 4 times 25 gives me 100, and then 100 minus 1 gives me 99. So there would be 99 circles in the 25th design, or the 25th step. Alright, next problem asks for the X-intercept of this equation, 3x minus 5y equals 15. Remember, for the X-intercept, the y coordinate is always 0. So again, essentially this y term will disappear. So again, with the X-intercept having the y coordinate always being 0, I take that equation, and where there's a y, I substitute a 0 in there. So of course 5 times 0 gives me 0. So that gives me 3x minus 5 times 0 equals 15, which just gives me 3x equals 15. Divide by 3, and that gives me x. The x coordinate is 5. Take that 5, put it right here where that x spot should be. And then that coordinate is 5 for x and 0 for y. Make sure you write it as a coordinate. For the y-intercept, you're going to do the opposite. You're going to plug in 0 for x. And again, for the y-intercept, the x-coordinate is always 0. So kind of think opposites. X-intercept, y-coordinate 0. Y-intercept, the x-coordinate is always 0. So in that equation, where there's an x for this problem from number 5, I'm going to replace that with a 0. And of course, anything times 0 is 0. So that will give me y equals negative 4 times 0 minus 5, which is just y equal negative 5. Take that negative 5, put it right there. And then that coordinate written is 0 for x, negative 5 for y. All right, next page. This problem's going to have you read this graph to find domain, range, max, min, increasing and decreasing interval. Range is always measured left to right. Range is measured from bottom to top, looking at the y-axis numbers. So again, range from bottom to top. This graph, because the line is going down forever, would have no bottom here. And again, since range is measured from bottom to top, it is going down. So that would be a negative infinity for the bottom of my range up to here to the top, which looks like just above 2, about 2.4. That would be a square bracket because that is not an open circle at that point. So again, range measured from bottom to top. Since that arrow is going down, there is no bottom, so negative infinity. 2 right here on the y-axis, about 2.4, and again that would be a square bracket because that's a solid circle right there. For domain, domain is measured left to right looking at the x-axis numbers. So the far left of this from here looks like about negative 4, square bracket because that's a solid circle, to positive infinity. I know that's going down, but again, domain is measured from left to right, and that does have a left to right aspect of it. I'm not worried about it going down. So yes, that would be from negative 4 square bracket to positive infinity for my domain. My minimum for number 8 is the lowest point. Since this graph has the arrow shooting down, there is no minimum. So I would just write undefined or no minimum, because again, there is no bottom of that graph. It goes down forever. So undefined minimum. But there is a maximum right here, the very highest point. I'm going to identify that, write that as a coordinate with rounded brackets. So it looks like about 2, negative 2 for x, and then up to about 2.4 for y. Always rounded coordinates for a bracket. For a coordinate. Rounded brackets for a coordinate. All right, increasing intervals. That is where my graph is going up from left to right. So my first interval where it's going up looks like from right about here, going up from left to right. Again, this would be decreasing, going down from left to right. So again, the only interval where it's going up is right here. From left to right, I would go uphill at that point. So now to measure that from left to right on the x-axis, from here, negative 4, square bracket, because that's closed, to right here, negative 2 on the x-axis. That's the only spot on this graph where that is going up from left to right. So negative 4 square bracket to negative 2, because those are closed circles. The decreasing interval, I have 2 of them, but I'm just going to write that as one interval, because from here to here it's all going down. So from negative 2 to positive infinity. And again, even though this is going down, intervals, just like domain, are measured left to right. That is going off to the right. So I'm not worried about it going down right there. So from negative 2, where it's starting to go down, all the way to positive infinity from left to right. All right, next problem. I believe number 12. has you take this problem in interval notation, which is from -7 rounded bracket to 4 square bracket. And again, to do this problem, I'm going to write set notation with my inequality with x sandwiched between these two numbers. And then again, this is my inequality. So that first inequality will be a plain inequality because there's no square bracket. And then between this x and this 4 will be the inequality with the less than or equal to sign. Remember, for these choices, the inequality always open from left to right. And again, of these choices, you need to match the inequalities with the interval notation. So again, this is a rounded symbol, so that would be a plain inequality. So this would be bad, bad. This one, only one that has a matching inequality. Number 4, square, would have a square bracket because of this inequality, less than or equal to. Again, that matches. This one would be okay. This one is bad. These choices right here are bad because of the two inequalities. The only correct choice for 12 is you sandwiching x between the two proper inequalities. Plain old x more than -7 and less than or equal to 4. And again, notice how those match these. Rounded bracket, plain inequality. Square bracket, inequality with the less than or equal to. So that only choice would be C on that one. So that would be set notation, and they have a little abbreviated form. They have just x and then this little line right here. -7 less than x less than or equal to 4. Alright, I'm going to shrink this up so I have more room. Problem 13 is just a inequality, and again, make sure you fix that on your paper. This should be less than or equal to 9. So make sure you make that change so that says less than or equal to. That will be a inequality. I'm sorry, it will be more than or equal to. So make sure you make that change on your study guide. So that would be -1/3 x plus 3 is more than or equal to 9. I'm going to solve this inequality by starting right away with inverse operations. Subtracting 3 on both sides gives me -1/3 x greater than or equal to 6. This is x over -3, but I'm going to do this as a reciprocal. So again, the opposite of multiplying by -1/3, because it will be written like this on the test, is multiplying by the reciprocal. So I'm going to flip that, keep that negative. These will cancel all the way and just give me x. On the right side, I make sure I multiply by that same reciprocal, -3/1. And again, to finish that up, these will cancel away. Because I'm multiplying by a -3/1, I need to switch that inequality from more than or equal to less than or equal to. And then over on my right side, 6 multiplying straight across gives me -18, and then that over that 1 times 1 gives me 1. So that final answer is x less than or equal to -18. If you did that on a number line, that would be a solid circle on -18 with the shaded arrow going off to the left, because that is x is less than or equal to. If that was interval notation, that would be a square bracket on -18. Alright, next problem, 14. To solve this, this is a just simple two-step inequality and put on a number line. Start by doing inverse operations, subtracting 6. This -4, -6 give me -10, but that does not switch my inequality. I'm not dividing by a -2 right here, so do not switch it. So when I divide by 2, the inequality stays the same. -10 divided by 2 gives me -5. That answer is x is less than -5. So that would be a open circle on -5, shaded arrow to the left. If I was to write that in interval notation, that would be a rounded bracket, -infinity, comma, -5, another rounded bracket because of this open circle. So again, x less than 5 would be a open circle on -5 because this is x less than big shaded arrow off to the left, all the numbers off here to the left of -5 are a solution to that inequality. So less than is off to the left. Alright, 15 to solve for x right here. I'm going to first start by multiplying both sides by 2. So I'm going to multiply the left side by 2. Multiply the right side by 2. That will cancel off those 2's off the top and bottom. And leaves me 5x plus 7 equal to 20. And then that's just a simple two-step equation where I subtract 7 on both sides. Bring down the 5x. 20 minus 7 gives me 13. And again, that will be a fraction here. Divide both sides by 5. And that gives me x equal 13/5. Go ahead and leave the fraction mixed. You do not have to worry about unmixing it. You will have a unmixed fraction on this problem. So leave it as a mixed fraction. That, if you were to unmix it, 5 goes into 13 twice. So that would be 2, and I believe a remainder of 2 and 2/5, I believe. Or 2 and 3/5. Alright, so here we go. Number 16. For 16, to solve this for x, I'm going to distribute. I'm going to look to make sure if I'm multiplying or dividing by a negative number to switch my inequality, I'm going to distribute. So start by multiplying -3 times 5x, -3 times 1, 7 times 2, 7 times -x. This will give me -15x minus 3. Greater than or equal to 14 minus 7x. Here I'm going to add 3 to both sides. So again, I'm going to start this just like a variables on both sides equation. Start by adding 3 to both sides. Make sure you add 3 to the number and not the term. Those will cancel away. Bring down the -15x, the inequality. 14 plus 3 is 17. Bring down the -7x, and now the crucial step. Now stay over on this side. Get rid of this term -7x by adding, and then go back to this side and do your division. So again, start on your left, go to your right, end up back on your left. So now I'm on my right side of my equation. I'm going to get rid of this variable by doing the opposite, which is adding 7x. -15 plus 7 is going to give me -8x. So be careful. It's going to be a tough negative integer rule problem right there. Bring down your greater than or equal to. Bring down your 17. Right there, divide both sides by -8, which will switch your inequality. Because remember, multiplying or dividing by a negative number switches your inequality. So inequality will switch from greater than or equal to less than or equal to. And then go ahead and leave that fraction as a mixed fraction, so -17/8. Don't worry about unmixing that. All right, 17 has you match the graph, and as you can see, just like the final exam, all of these will have the correct slope over 4. 1, 2, 3, 4, down 3, a slope of 4. -3, -3 over 4. -3 is my run. 4 is my run left to right. -3 is my rise. So all these have the correct slope. All of these have the correct y-intercept of -1. You need to just pretty much match the problem that has the correct inequality with this graph. And as you can see, they have a slope of run of 4, rise of -3, so that put together as rise and run is a slope of -3/4. So all those are good. All have the same y-intercept. Now for the line itself, this is a dotted line, so that would be a plane inequality. So this choice is a bad choice right away. So choice B, because that has that line under there, that would be solid for that, but that's incorrect. So again, choice B is wrong. Now this one has you shading above. Shading above is always the inequality more than, which looks like this. Less than looks most like a capital L. So that means the only choice that's correct is choice C. Choice A would be incorrect because that has less than, which would be shaded below, but this is shaded above. So that right choice is y more than negative 3/4 x minus 1. So plane inequality, dotted line, over 4 down 3, negative 1 for my y-intercept. All right, for 18. For this problem, I'm going to solve it for y first. So get it in slope-intercept form first by subtracting that 3x. That will not flip my inequality. Remember, only multiplying or dividing by a negative number flips your inequality, so leave that alone. It's going to be y less than or equal to negative 3x plus 4. It's going to have a y-intercept of 4, a slope of negative 3 over 1. So I'm going to go up to 4 on my y-axis. And then from there, every time I go over 1, I'm going to go down 3. Over 1, down 3. That would be a solid line. L. Because that line is less than or equal to, I will shade below that line. So solid line, shade less than, down below. And again, less than always below, more than always above. Doesn't matter how the line is drawn. Less than below, more than above. Solid line because of that inequality. Next problem. E. For this problem, number 19, I'm solving this literal equation for C. So for this problem, I'm going to get rid of all the terms around that C term by adding or subtracting first. So that 32's got to go first. So I get rid of that 32 by subtracting 32 on both sides. And then once I do that, now I could worry about that mathematical operation in front of C. So I get F minus 32, because I cannot combine those, equals 9/5 C. Or if I want to flip that around, I could write that as 9/5 C equals F minus 32, if that makes you feel better to solve it like that. Now to get that C by itself, I need to get rid of that 9/5 term. So I'm going to multiply by the reciprocal. So the reciprocal of 9/5 is 5 over 9. So I improperly write that as 9/5. So I will go back and fix that. So again, multiply by the reciprocal, not by the same fraction. So I'm going to erase that. The reciprocal is 5 over 9. So multiply both sides by the reciprocal. This will cancel away because you get 45 over 45, which is 1. Over here it's harder because I need to distribute 5/9 times both terms inside here. So 5/9 times F will give me 5/9 F. And then 5/9 times 32 is harder because I gotta pretend like that 32 is over 1 and multiply straight across. Multiply 32 times 5 and 9 times 1. So again, when I distribute, I get 5/9 F minus, and then 32 times 5. 5 times 2 is 10, carry the 1, 15. Plus 1, I believe I get 16. So 160 over 9. So again, that answer solved for C is 5/9 times F minus 160. So again, if you wanted to convert from Fahrenheit to Celsius, you'd plug in the degrees Fahrenheit right here, multiply times 5/9, and then minus 160 over 9, and you would get the degrees Celsius if you wanted to change it from Fahrenheit to Celsius. All right, next literal equation has you solve this equation for W. So this is P equals 2L plus 2W. That is perimeter. So the perimeter of a rectangle, you add the 2 lengths and you add the 2 widths. So that is the equation perimeter of a rectangle. 2 times the length times plus 2 times the width. I'm solving this for W. So I'm going to solve this literal equation for W. So again, to solve for that variable, look to add or subtract any terms around it first. Just like that problem above it where I added subtracted first, same thing. Look to add or subtract a term away first. That gives you P minus 2L equals 2W. And now to get that W by itself, the opposite of multiplying by 2 is dividing by 2. So I'm going to divide both sides by 2. And then that 2 will simplify this out to give me p over 2 minus, and then these will cancel to give me minus 1. So either write it as this or simplify into p over 2 minus L, or minus 1L, because these 2's cancel away. So again, width would be perimeter minus 2 times the length over 2. And again, I will change that so that's not a W, that would be a 2 right there. All right, problem 21. It gives you the first term. It gives you the recursive formula. It's having you find the next 4 terms. So that first term being 5. And then the recursive formula says to find each next term, use the one before it and times it by 3. So again, this is the term before it times 3. So to find that next term, use the term before it, which is 5. And times it by 3. That will give you the second term. And again, to find that third term, use the term before it, times it by 3, and that will give you the next one. That's recursive pattern, using the one before it and the operation that you're doing from the recursive formula right here. So that would be your common ratio, because this is multiplying. This is a geometric sequence. So again, to find those next 4 terms, start with 5. And then take that 5, multiply by 3, and that will give you the second term, which is 15. To find that next term, takes 15, times that by 3, which will give me 45. Take that 45, multiply that times 3, and that will give me 135. And then when I multiply that times 3, that will give me the last term, because again, I'm trying to find the next 4 terms. And then that will give me 405. So those next 4 terms are 15, 45, 135, and 405. If you wanted to find the 0th term for this sequence, again, if I'm timesing by 3 going to the right, I'm going to be dividing by 3 going to the left. So again, to find the 0th term for this sequence here in number 21, where that first term being 5, and then again, knowing my common ratio is timesing by 3. So again, timesing by 3 going to the right, I'm going to be dividing by 3 going to the left. So that 5 divided by 3, or that 5 times 1/3, because remember, dividing by 3 is the same as timesing by 1/3, would give me 5 over 3. So again, if I was to write the explicit function, that would be f of x equals 5 over 3 times 3 to the x power. If I wanted to use the new way with the f1 term, that would be f of x equals 5 times 3 to the x minus 1. So again, make sure you could write the explicit function for these geometrics both ways. F of x equals 5/3 times 3 to the x, or f of x equals 5 times 3 to the x minus 1. But again, back to this problem 22, all they want you to do is to divide by 3 going to the left, and then 5 divided by 3 is 5/3. This problem is growing geometrically. It is growing exponentially. Here we go. Make sure you know both those terms. Geometrics always have that exponential look, that curved line, just like that. All right, 24. In this sequence, they're going to have you write the explicit function and then evaluate that for the 12th term. So again, I'm going to find the first term there, which is 2. That's a given. I'm going to use the new explicit function, which has me use that first term and that number I'm adding each time, which looks like 3 for this sequence. So to find that explicit function, use the first term 2, and then use that d number, which is 3, my common difference. That would be 2 plus that d number 3 times x minus 1. And again, you could write that 3 in the front of the parenthesis x minus 1 or on the reverse side, but either way you will have to distribute. So I'm going to multiply that 3 times x and that 3 times negative 1 and then combine like terms. So I get 2 plus 3x minus 3. Combine my 2 and minus 3 to get f of x equals 3x minus 1. And again, I'm going to use that to evaluate the 12th term. So using that explicit function, where there's an x, I substitute that 12 in there. 3 times 12 gives me 36, and then that 36 minus 1 gives me 35. So in this sequence, the 12th term would be 35. It makes more sense to use the explicit function to plug it and jump ahead rather than to keep adding 3 until you get all the way to that 12th term. So again, when you're jumping ahead, use the explicit function. When you're trying to find a term right next to the next one that you have, use the recursive pattern. All right, problem 25 has you write the explicit function using the first term instead of the 0 term. So again, for this sequence, I have 1, 4, 16, 64. That is a geometric sequence. My r is 4. I'm multiplying by 4. My first term is 1. So again, to find that explicit function, all I have to do is plug in that first term 1 times that r to the x minus 1. So that answer would be f of x equals 1 times 4 to the x minus 1. What I'm doing here is showing you the old way. Again, you could write that 0 term times r to the x, or you could write this with the first term times r to the x minus 1. This problem has you use that second formula. So again, when I get that answer, which is 1 times 4 to the x minus 1, the only correct choice is C. Choice A is bad because it has kind of like in the first term look to it, but that is the incorrect first term. I'm sorry, or 0 term, so A would be incorrect. And then this has 4 times x. Geometric always has x in the exponent spot, so B would be not good either. All right, number 26. 26 has you take those problems, distribute, and simplify to see which one matches the one they're giving you. So the one they give you is f of x equals 5x plus 1. Which one of those choices distributes and simplifies that gives you 5x plus 1? So that first one, when I distribute, I get negative 5x plus 5. That's 6 plus 5 would give me 11. That negative 5x, already a bad choice. Choice B, if I have that 1 right there, I believe, plus 5 times x minus 1. Again, I will distribute that 5 times the x, and 5 times minus 1 gives me 1 plus 5x minus 5. 1 minus 5 is negative 4. T. So again, that is a bad choice. This problem right here, when I distribute that 5 times x minus 1, I get 5x minus 5. I will go back to that, I promise. And again, choice C is the only one that distributes to give you 5x minus 5 and just combine with that 6. So that would be choice C for that problem for 26. And then again, one more time, I'm sorry about that, the way this got cut off right there. And right there, that's 6 and that minus 5 combined to give you 1. So that would give you 5x plus 1. So C would be the only good choice. A and B would be bad. That is the end of part 1. S. Make sure you're listening for part 2. G.